class. Today we are going to look at what we refer to as what? Business statistics. Before we proceed, it is better we actually understand what we mean by the word business statistics. The word business actually stands for an enterprise. The word statistics search for what we refer to as what? City pie. What do I mean by the word city pie? It is simply referred to as statistics can be defined as a what? As a collection of what? Tabulation, which involve also presentation, analysis, and interpretation. And how do we put it in a formal sense? We say statistics can be defined as a collections, tabulations, presentations, analysis, and interpretation of data. Now, what do we mean by all this expression? We simply mean that before you can go anything in terms of the word statistics, we have to undergo what we refer to as what? Collection. What are we collecting? We are collecting data. We are simply collecting what? Data. Now, when you collect this data, you have to tabulate it. You have to present it in a format that will be what? Readable. That's where we come across what we refer to as what? Presentation. Then after your presentation, then you need to analyze this data that you gather, that you have presented in a tabular format. That is what we refer to as what? Analysis. Then after that, then you now interpret it in a readable format in which you can use it or you can store it for future purpose. And that is all what statistics is all about. Again, I repeat, statistics can be defined as a collection, tabulation, presentation, analysis, and interpretation of what? Of data. We need to look at the uses of statistics in management. So statistics in what? In management. Now, one of the things we use statistics for or use statistics for in management is one, government use. Government make use of, one of the people that actually make use of statistics as a whole is what? The government. And what do they use it for? They use it to interpret their income and what? Expenses. They use it to interpret what? Income and expenses. Now, how the money is being generated and how they are being spent. Now, they can use that to project for next year. You always hear 2010 budget. We hear 2011 budget. We hear 2012 budget. How do they come across this? It is through statistics. Without statistics, it will be absolutely impossible for government to propose a budget for a particular year, because it is these statistics that will determine, okay, on oil and gas, we spend 2 million naira. Okay, this particular year. Now, in the next year, with this particular help, they can project that, okay, this is because of inflation in this and in that, the amount that will be involved will be 2.5. Now, another way it also helps government is to determine the volume, the number of employment and people who are not what? Who do not have what? Job. Employment and unemployment. They use it to determine the number of the people in the labor market and people who are what? Gainfully employed. Now, another way we also use statistics in management is what? To formulate policy. Without this, to gather policy or to derive policy in an organization will be absolutely impossible. Also, we also make use of statistics to allocate actual resources efficiently. And again, for a country to grow, it has to make use of what? Statistics, because it uses in its analysis and in measurement of its developmental what? Growth. Now, we have to look at the way in which statistics are what? Being presented. Now, statistics can be looked into under what we call sample and under what we call what? Population. Now, what do we mean by the word sample? Sample is just a collection of a part out of whole. In the country called Nigeria, we can decide to pick a portion called Lagos State and then based on our findings on Lagos State and then generalize the findings in a country called Nigeria. Now, what we are saying is that sample is simply referred to as a part of a whole. Now, what do we mean by a part of a whole? When we consider a country Nigeria, now, if you want to perform a research and you now specify your research in Lagos State, for instance, or you decide to pick Abuja as your case study, then you find out that picking a particular place for a case study, then you are actually undergoing what we call what? A sample. Then from there, you can now generalize your result to a country Nigeria. Now, in this sense, we find out that sample is more efficient, is cost effective than what? Population. Because you can imagine, if you are considering a population and you want to conduct a research that involves traveling all over the nation, you find out the amount you incur in transportation, in feeding, and all of that. But if you are considering picking a sample for your procedure, then you find out that there will be reduced in price of your research. And also, it saves time, because the time it will take you to travel from one country to another in gathering your data, you find out that picking a particular location and do that, you find out that it is much time effective. Also, you can easily minimize volume of what? Errors. You can easily what? Minimize volumes of errors. And finally, the rate of accuracy in terms of what? In terms of sample is very high compared to population. Now, what we are trying to say in these two is that if you want to perform a statistic research, you either pick sample or you undergo a population. Population is when you are performing a research on everything, on every area that you have in gathering your what? Data. But picking a particular portions of that area, then you are referring to what? You are referring to sample. Now, what are the quality or the quality characteristics, as the case may be, of what? Of statistics. One, for you to have a good statistic research, it must be what? It must be simple. It must not be cumbersome. When you are gathering your data should not be what? Should not be what? Cumbersome. How do we gather data? Gathering of what? Gathering of data. Now, data can be gathered in this format. Now, you can use what? Questionnaire to gather what? Your data. You can also make use of what? Interview to gather what? Data. When we say questionnaire, what we simply means is that a questionnaire is when you type out your questions. You list out all the questions you want to ask. What are you doing research on? You write out everything about that research, then you write them down and start asking them, either by posting it, by sharing it, or by asking people on that particular subject. Then that is what? About what? Questionnaire. Now, in terms of questionnaire, you find out that questionnaire has its own advantage and disadvantage. Now, what are the major advantages of questionnaire is that, now, it will give room for wide varieties of opinion, because you can able to spread out your questionnaire. You can distribute it by posting and the rest. You find out that it will go a long way in gathering data for you. And then when you're actually presenting your questionnaire, you should find out the area in which you're actually specifying, so that you will not just be voluminous in terms of your question gathering. Now, your question, in terms of the questionnaire you prepare, it must be what? Simple for people to actually answer. Now, the reason why it must be simple is simply because you are not going to be there when they will be answering these questions. And since you are not going to be there when they are answering this question, it is important for you to make questions that you are asking very simple. Also, it must also be what? Clear. Your questionnaire must also be presented what? Clear. Apart from questionnaires, another one we have is interview. Now, when you find out in the process of interview, you find out that it is what? It is more efficient than questionnaire. Why? Because is very, very efficient in terms of you'll be able to see people you are talking to, people you are actually interviewing. You will see them face to face and able to ask questions. And some question will bring about asking another question in actual for you to get your facts. But it has some limitation in terms of data gathering. Why? Because the person you are interviewing can be partial. Because you are there, he could not be able to express himself to the detail. He will want to favor you in terms of answering your question. So it could be what? Partial. But if you actually make use of a questionnaire, that person will actually what? Will not bother about who is going to receive the data. He will just make sure he answers the question according to his opinion. But in terms of interview, he will want to favor the person who is what? Is presenting the question or who is trying to gather the data. Also, the advantage here is that a non-numeric and numeric data can be easily what? Gathered in terms of interview. But in terms of the questionnaire, to gather a numeric data is always what? Difficult. Now, earlier I mentioned numeric and non-numeric data. Data are divided into two. And what do we mean by data in the first row? Now, data is referred as a collection of facts. That is what we regard as what? Data. Now, data and information, we should take note that they are not the same. Why? Because we said earlier that data is a collection of facts. But information is the what? Is the processed data. What do I mean by that? That the data that you've worked on, that you've processed, you've put a lot of seasoning into it, are what becomes information. But the data you gather, you collect from A, you collect from B, you collect from C, are not information until you work on them. Extraction, addition, deletion, and modification. Then it becomes what? Your information. Your data, when you gather data, your data can be gathered in two forms. It's either in numeric or as what? Non-numeric. Now, what do you mean by numeric? Numeric is a gathering of numbers. A data that involves what? Numbers. These are what? Data which are involved in what? In values. Now, what do you mean by in values? That you can count. These are countable what? Data. And we have it in two forms. This numeric data is divided what? Into two forms. We have the discrete and what? Continuous. We have what? Discrete and what? Continuous. Now, what do we mean by the word discrete? Now, we simply mean, when you're talking about what? The discrete, these are precise value, numeric value. Precise, like integer. 2 is 2, 5 is 5, 10 is 10. Those are what we refer to as what? As what? Integer. But when we're talking about continuous, these are variations value. These are number in varies, that is not constant. Then we can talk about a real value. That is in terms of what? In terms of what? Continuous numeric data. Now, the next thing we're going to look at is source of data. Source of data. Where do we get our data from? We have two sources, which are what? Primary source and what? Secondary what? Source. Now, when you say primary source, what we simply means is that we are getting this information directly from the mainstream, from where the origin of the data. That's what we mean by what? Primary source. And when we talk about secondary source, what we are simply saying is that we are getting it from a third party. It's not the origin, but we are getting where the origin was being taken from. That is what we mean by what? Secondary. What are the limitations of what? Of primary data? Now, you should know that when you're talking about when something is from a primary, that means it's crude. Is very crude because it is not refined, it is just directly from the source. But when you're talking about the secondary, you find out that it is quite improved by the primary. It has been quite refined before being proceeded as a secondary source. We look at what sampling techniques. What I would mean by sampling techniques? Now, we have various types of what? Of sampling techniques. We have what? The simple sampling technique, the cluster sampling techniques. We have the stratified sampling techniques, and we have the systematic system technique. Now, what do we mean by simple system technique? This is a technique in which we perform our sampling just based on random picking, random selection. We base it on what? On random selection, on probability. That is what we refer to as what? A simple sampling techniques. Also, what do we mean by a cluster sampling technique? Now, it's a sampling technique where populations are divided into small geographical zones. When you have a population and you now divide it into very, very little ones, then you are saying you're what? Performing your sampling technique based on what? A cluster. And also stratified. When do we call it a sampling technique to be what? To be stratified. It is when a sampling is divided into station. That is, divided into homogeneous. What do we mean by that? Divided into, we gather the source of data that are the same. We group them into one and perform sampling into them. The one that are, we don't group, when we are performing a sampling techniques on a country, Nigeria now, for instance, we gather the Hausas, we group, we perform research on various groups that we have in the north, and in the southwest, various ones, we pick them and select them variously in terms of the Lagos, the Oguns, within the southwest, we perform. That is what we mean by homogeneous, that they are the same. And the systematics, this is a population that involved in serial format. Is a sampling technique that is what? That undergo a serial performance. 1, 2, 3. So we don't just jump. We have to undergo stages by stages in terms of what? In terms of the techniques that approach. Data measurement. Now, how do we measure data? Now, in terms of measuring data, we find out that the simplest way to do that under statistics is by undergoing what we refer to as what? Data tabulation. Now, before you can actually measure data accurately, you have to present your data in a tabular format. Now, what do we mean by that? Now, in a class, let's say we have a class. In a class that involves number of students. Let's say we have of various age. Let's say we have 5 students. Now, in the 5 students, we have 25 students. Let's say, for instance, we have about 25 students. Out of these 25 students in the class, we have of various age. We have 12, we have 15, 12, we have 13, we have 14, 16, 17, we have 12, 13, 10, 8, 16, 18, 12, 12, we have 14, we have 16, we have 13, 14, 10, 16, 8, 10, 10, 11, 1, 2, 3, 4, 5. So we have students of this age range in a class. Now, when we are gathering this data to know the age of each in our class, and we found out that each of them has this specified age. Now, what are we going to do? We have to present this in a table. Note one thing, that data can be either a group or what? Ungroup. Now, what we see here is a typical example of what? Ungroup data. The data that has not been grouped. You understand? Now, if I want to present this in a tabular form, then it can simply be referred to as what? A group data. So how do I do that? I will just say age. I will just say frequency. Now, what do I mean by the word frequency? I mean the number of what? Occurrence. How many of this particular age can be found at this particular time? Now, let's look at it. What is the smallest age that we can find here? We find 8. We can find 11. We can find 10 next. We can find 11. We can find 14. We can find 15. We can find 16 and, okay, we can still find 17. We can find 18. Now, in this now, we have how many 8 can we actually get here? Let's see. We have 1. Then we have the second one, which is what? 2. Now, let's look at it again. Let's see 10. How many 10 can we actually see here? 1, 2, 3, 4. We can see 4. Then how many 11 years can we see here? We have 1. We have 1. We have 1. And then there is only just 1. Now, how many 12 can we see here? We have 1, 2, 3, 4, 5, 11 years. Now, how many 13-year-old can we find here? 1, 2, 3. We can see three of them. And how many can we see as 14? We can see 14, 1, 2, 3, 3. Now, please, it is very important for you to take note that it is better if you can be crossing it out as you are picking. Let's just a little bit refresh back to the beginning. We say 1, so that you can know the one you've picked, so that you'll not be picking twice. We're picking 8. We said we see 2 8, and we've picked them out. We said 4. We said 4 10, right? 1, 2, 3, 3, 4. So that any time you come across a one you've not picked, you can easily identify and add it to that number down. So we've picked 11. So we have only one of the 11, so that when we come across 11 again, we'll just know that we need to increase this. Then 12, we said we see 5, 12. Let's see again. Let's look at it again. 1, 2, 5. Okay. Now 13, we have 1. We have 1. We have 2. We have 3. Then let's see 14. We said we have 3 of them. So which we have what? 1, the 2, and then the 3. So let's see again. Now, how many 15 can we see here now? We're not seeing any. Okay. Then 1. Just 1, 15 years. And then 16. We look at 16. 1, 2, 3, 3, 4. I see 4, 16. Then on the 17th part, how many do we see? We see 1, and then, okay, just 1. Okay, and the 18, then we only see 1. Now, if you actually look at it now, you find out that we've ruled out every number. That means that we've done justice to all the ages that we see there. Now, looking at this now, this look more presentable. What this simply telling us is that we have how many in this particular class? We have 2 people or 2 students who are of age 8, 4 of age 10, only one student of age 11, only 15 of age 12, and then now looking at this now, when you look at your frequency must, the totality of this particular value must equal to 25 students. Let's see. 2 plus 4, 6, plus 1, 7, 12, 15, 18. Now, we said we have 25 students in a class. Now, out of the 25 students, we have these various ages that we have here. We have 12, we have somebody who was 12, 15, 12, another 13. Now, we refer all these written as what? Ungrouped data. Ungroup data. Now, in terms of the ungroup data, we have this. Now, we can make this ungroup data a grouped data. Now, we can group them 18, we gather them at the side. Those that are 5, those that are 10, we gather them at the side. So from there, we can now make age out of this. We can now make what? The number of this particular age that we can see out of this. Now, looking at this, now if you look at all this written on the screen, we find that we have 8. Now, how many 8s can we see in the whole of these data? We say we have what? Just 2. How many 10 can we see? We have what? We have 4. 11, 1. 12, 5. How many 13 years can we see here? We have what? We have 3. How many 4 can we see? We have, how many 14 can we see? We have 3. How many 15? Just 1. 16, 4. 17, 1. And then, how many 18 years can we see here? We find out that it's just what? Just 1 person or 1 student. Now, after making this now, we can present this in a chart format. We can present this in the what? In a chart format. And we have various charts or various chart representation we can use to present this particular data. We can decide to present it in form of a bar chart, what? A pie chart, frequency distribution, histogram, and in form of what? Histogram. Types of bar chart. We have the simple what? Bar chart. We have the multiple bar charts. We have post bar. Now, how does this chart look like? Simple bar chart. Now, constructing a simple bar chart for this, we now consider a line. Note that this should be on your graph. And then you should know that the first thing you have to do when doing a graph, you have to the scale that you are making use of. Now, that one comes simply by the use of your what? Now, let's assume that based on ruler, we have this place to this place is 2 centimeters. And then if you notice we have various cells where we have a bold one after 5 count. Then you can say that 2 centimeters represent 1 unit. Now, be that as it may, now let's consider the simple bar chart for this. This particular side, we have 2 ways of drawing a simple bar chart. You can start to draw it horizontally, or you can start to draw it vertically, or based on the question given to you. Looking at this now, we're going to construct a vertical simple bar chart, where it's going to raise it up like this. So let's consider the frequency at this side, where we have just 1, 2, 3, 4, 5. Okay? So that means 2 centimeters represent 1 unit. This side now, age 8, age 10, 11, 12, 13, 14, 15, 16, 17, and 18. Now, putting all this, we now can now put, okay, where does 8 stop? It stops at 2. We have this. What of 10? 4. We have this. And then 11, we have just 1. So we're going to go here and stop. Then we have 12, which is going to go up all to 5. If you look at it, it must be there. So we have 5, then it comes down. Okay, then we have the 13 to move up to 3. Then we have 3, then we have coming down 3. Then 14, we have also 3. It's going to 3. Then it's going. Now, you should know that this should be, if you're using it on the graph, it will be more smoother and to be considered. And there should be space in between. That is one thing you should take note of. Bar chart. There must be space in between your drawing. You are not drawing to, you are not tightening anything. And that will explain when we get to histogram where you have to compress everything together. So that is the difference between these and histograms and other features. For the 15 years, okay, we have just one, the height of 1, which is starting here and ending here. For the 16, we have just 4. You should know that you are going to make use of ruler in times when you are making your drawing. So we have this, and for 17, we have just 1. And 20, we have, for the 18, we also have just 1. Now, the next thing we need to consider here is you can paint it to differentiate it from the white background or the background so that they can identify your diagrams in it, as it were. So, we have this. So this explains a simple bar chart. So we have this, we have this, okay? Now this explains a simple bar chart as it is, as you can see on the screen. Going again, we have a multiple bar chart. But before we continue, that means we have to rewrite our data, because this data can only be suited drawn on a simple, just for a simple what? Bar chart. Consider another a group of data. Let's consider to the fact that we have male and female. You understand? In this particular category, we say we have male and we also have female. So let's say, for instance, we are still going to assume that this particular 8-year-old include male and female. So which we are going to show very soon here. So we are still going to make use of this. So this one will now include gender. So we're going to have gender here and we're going to have frequency here. Okay? But this is still under age 8 as the class. Now, here we have male, female, which is 2. Male, female. So we're going to divide this into, so let's say we have male 1, female 1. So this place was 4. So female, female. So it will be what? We say we have 1, 3. Let's assume to have that. And this one is 1. Let's say we have just 1 male, no female. And this place is 5. Let's say we have 2, 3. So which we have as male, female. And then this is also what? This is male, female, which is 1, 2. This is also 3, which is also 2, 1. Let's put it up with 1. And then let's say we have just 1 male, no female, which is we have people who are 16-year-old, we have 4. We have male to be 2 of them and female to be 2 as well. Year-old in the class, we have just 1 female, no male of that age. And 18 years we have, let's say we have 1 male and no female of that age. Now, reconstructing this particular drawing to suit I'm going to present a composite bar chart first before we move to multiple. Now, in terms of the composite, we're now going to divide this, we're going to split it into the value that we have here. You know, this place ended 1, if you notice, so this place will be this. So look at it. Now, from this, we can differentiate that. We can now indicate. Now, when you are making such drawing, you are going to indicate the logo for the 2. Let's say this one that is in form of a net is for male. And then the only cross one is what? So anyone that is reading it will know that the first one is for the male, the second is for what? Is for the female. Now for the second one we have male to be 1 and the rest are what? Are females. So that means I'm going to put a cross like this. So then I'm having now a female down. Then for the 11 years old we say we have male. So that means that I'm going to cross, I'm going to net it. I'm going to net this. So we are now having only male existing at that particular end. We have 5, then we have 2 males, so our 2 will be here, So the rest here are what? Are female. So I'm going to cross it. So you should look at this particular crossing as it is to this, so that we can use it to determine which ones are male and which ones are what? Female. For the next 13, we have just 1 and 2, where we have this 1, and then we have this, then we have this 1, and then the 2, remaining 2. Now, if you subtract 1 from 3, then we have 2. So that means from 2 here to this is female. Then for the 14-year-old, where we have 2 male and 1 female. So we have 2 male. So 2 male, let's cut it. If you look at it from there, we see, so as well, the remaining one is what? Is female. Then if you look at the next one, where we have 15 years, where we have only just the row 1, just 1 person. So it's the female. For the 16, we have 2. They are both shared. So that means we're having 2 to be females, and the remaining 2 to be what? To be females. For the 17 years, we have just females, so it is a female. And for the 18, we have... So this is referred to as a composite bar chart. Now, what we are simply... The difference between this and this is that for the multiple, you are going to bring this down. You understand? We're going to bring it down. We're not going to present it in that on top of it. We're going to bring it to the side. So let's see how that will go in our next diagram. Multiple. For multiple. So what do we have as multiple? So like I said we're going to present it just the way we presented it the other time. But the difference is that it's going to be side, not on each other. So we said we're still going to maintain the drawing that we make the other time. So what we have here is, we said we have, this is 1, this is 2, 3, 4, 5. So 1, 2, 3, 4, 5 as it were. So now what we are going to have here for the 8 years old, we're going to have just 1, right? So this 1 hence here, this for the female, this for the male, for the female, for the male. So the male is going to be like this. So this is the female. Now you see, unlike the first one we saw where it was on each other, you understand? So this one is by the side. So looking at this one now, for the 10, that means that the female, for the 10-year-old, so it will be male 1, female 3. So it's going to climb to this extent. So climb all the way to 3 and come down, you see? So we have the female here. And then we have the male here. You see? The male is here. And if you look at this, I'm actually bringing male. So we can, it doesn't matter whether you bring the male first or second, but it's better we put it at the same side. So if all males are the right left-hand side, let all the females be at the left-hand side. So that it will be the same for the 2. 11, so we're going to have 1 for the male and none for the female. So we're going to construct only 1, so which is going to be just this. So we're going to have this. I'm going to have this. So we've seen this as it is. So for the 12 years, so we're going to put the 5th and the 7th together. So which is going to be M and F. So M will be what? 2. Go to the height of 2. And note that this will be drawn better on graph as it is. So we have 12, and the female will be 3. So we have this. So we are having a male here, and then female here. So I employ all of us to practice the rest as the case may be. Now the next chart we'll look at is the pie chart.
Now what do we mean by the word pie? So it's also
another way you can actually present your data. And how do we do this? It's going to be in a circular format that we're going to present the data.
Now the next one we're going to look at is the pie chart. Now, in another form we can actually represent the data apart from the one we explained earlier, which is what? The bar chart. Now, in the pie chart, what do we say? Let's assume we have this kind of question.
The distribution of junior workers. The distribution of junior workers in an institution. This institution is as follows. So let's see the distribution. So we have clerk. How many? We have 78. We have drivers. We have 36 of them. And then we have typists. We have just 44. We have messengers. Okay? Messengers are just 52. And then we have others, other junior workers in the company, which are made up of what? They are just 30. So pie chart is represented in form of degree. You know, if you consider the angle of a degree is what? 360. So that means that the totality of this circle is what? 360 degree. So we're going to base this fact that we gather under what? The 360 degree. So that's how we're going to represent this data. But first of all, the first thing you must consider is the additions of all these values. What are the additions of this going to give us in terms of what we actually expect? They have 240 junior staff. So in terms of this, then, we are now going to narrow this down to this particular circle that we have here, which is made up of what? 360 degree. Note that if you are making up a pie chart and it's circle form, you should know that it is in terms of 360 degree. Now, if you are considering the value now to fix it in, that means that we have to narrow this down to suit in these 360 degrees. So how are we going to do that? And we're going to do it in this way. We're going to divide this particular, each of these by this total. Then, in place of 360 degree, we have 38 divided by 240 times 360. Now, I want to know the portion of these out of this 240 in place of 360. So that is what we are trying to do here. So if you multiply these, if you divide these or you multiply this with this and divide these, we are expected to have a value called 117 degrees. So we can press our calculator. You don't have to stress much on that. And if you don't have, it's a simple thing to proceed with. Just divide, 0 will cancel 0. Then how many of these? What can go here? 6 can go here 3, and then 6 can also go here 6. 6 can go here again, 3 can go here 1, 3 can go here 2. If you multiply this by this, we'll get, if we multiply this by this, we are going to get 117 as it were. Okay, 6, 3. Okay, this is 6. This will be 4, not 3. Sorry, this will be 4. Then this will be what? This will be 2. Okay, this is 4. This is 6. This is 2, 2. So we're having, this is 3. And this 1 will get, this is 2 here, it will be what? It will be 3. And this it will be what? 19, 39. So we have 39 times this. We're expected to have this particular value. Also, the same thing you will do for, that means that for clerk, we have, it will take a portion of 117 degree. So for driver, it's going to be the same thing, 360 over 240 times 360. 36 over 240, 36 of driver out of what? 240 junior staff in place of 360 degree. So which is going to amount to 54 degree. If you multiply and divide, you will get that. We have 44 over 240 times 360 degree. So if you multiply this and divide, you are expected to have what? 66 degree. That is for the typist. For the messenger, okay, let me just denote it. So we have D, and then this is C. So for the messenger, we have 54 out of 240 of what? 360. So that means that we will get of that. If you make your calculation, you will get 78 degree. And for the other people in this junior staff category, which are 30 out of 240, if you multiply by what? 360, then we will find out that we will what? 45 degree. 45 degree. Now, looking at all these values that we gathered, if you had them, you must get a value called 360 degree. Any answer other than that, you are what? You are out of it. So then, in case of that, you should go back and try to recalculate what you have. Probably there is a mix-up in your calculation. But if you add them together, you are expected to get, because if you add this together, you are expected to get 240 as the total number of staff. And if you add a degree, because you are placing them in position of degree, you are expected to have what? 360. So how would that go? So let's test that. 117 plus 54, that would be what? This will give us 1, this will give us 71, yes, so 171 plus 66, then that will give us, if you must add this together, 237, then if you add 78 to it, we have, this will be 1, this will be 13, and then if you add this 1 to it, then 45, then you should see definitely we have what? 360. To draw this, you are going to hold on to your compass and then your pencil as well. So to do this, you have to locate the center, because I can't actually use a compass on the board. So I'm going to make use of an assumption drawing on it. So if you try to trace that, you're going to have what we refer to as, if you look at this, this is okay, let me just make it traces. This, this is half of 360 is definitely 180. So this is 180, this is 180, and then this is portions of this particular portion is 90, 90, because now 190 plus 90 will give us 180. So also at this level, so that's 90, 90, 90. So I can now, let me see how I'm going to break it. So we have 45 here. So that means I can take one portion and divide it into 2. Then I will have 45 degree Celsius. So 45 degree, as to say. So that means definitely this is my portion. For what? For others. So others, which is 45 degree, will take this portion. So O stands for others. So looking at the other ones, so we have 54 here. So 54 can take a little bit above 45 degree. This is in terms of 180. So that means my drivers, the drivers will take a portions of this is an assumed driver, which is what? 54 degree, which is more than 45 degree. So looking at that, then we also have the next one. So let's take a very large portion of this, which is 170. This is 90. The whole of this is 180. Now, take the remaining 90. Then that means we have 27. So that means we have 27, a little bit more in this direction. So from here, okay, let me consider this side. Okay, so say this is 45, and then 45 plus 90, that will be 135. So I'm going to have somewhere around here to be my 117. So 117, so taking this out, I've cut this out, and one thing we must take note is that when this we had it and everything is 360 degrees, that means all our values occupy this position. So we have one, this is taken care of, this has been taken care of, this has been, so we have this. So the remaining have to be shared between 78 and 66. Let's see 78, let's consider it to be in this format. So we have this place to be 78, then definitely this is what? 66. So this place is for messenger, while this place is for typist, while this is for the clerk. So this is an assumed pie chart of drawing of this particular question, as it were. The next one we're looking at now is the histogram. If you look at it, these are a compute data, a standard compute data for an examination. If you look at this, say the weight to the nearest gram of a group of 50 students. So these 50 students are gathered in a place of in a college of technologies, and then they consider their weight. Now the weights gathered they have, we have 65, 70, 60, 40, 46, 51, 55, and so on and so forth.
Now if you look at it, these are number
of different weights of 50 students. So the total students that we have here are expected to be 50. Now, one thing is that Like I said earlier, this is a format of ungrouped data. We are looking at the smallest weight that we can find here. Now, the smallest weight we can find here, we find out that if you look at it from the beginning to the end, you find out that the smallest weight that we can locate here is 50/45, so to say. And then, now, depending on the volumes that you have, here we have 50. And make your class interval 4/4, you can make it 5/5, you can make it 10/10 as the speed. If you look at this one now, 45, 46, 47, 48, 49, just 5. So we split it into 5 because they are not much. 5 times 1, 2, 3, 4, 5, 6. So this is 6 as a range. So that means that we said that the first range of set of people are expected to have the weight between 45 and 49. So we next have to pick between 50 and 54. So having that, so if you look at it, we have 51, range to 51, 53, 53, 50, another one, that is 1, 2, 3, 4. So let's see, between 4, we've picked 4, so 5, so we're picking 5, so we have 6, 7, 7, 7, 7, 7, 7, 7, 7, 8. Okay, there's one we have omitted. So in the course, so okay, I've seen it. So this is the 9. True again, we will not have seen anyone. That is why I said that it's better you cross out so that you can easily identify the unpicked. If you go through this, I want you to go through it, you'll find out that the rest that I picked are as that. So if you had all these things, it's expected to give you 50 because we're actually having 50 students. So the next thing we're going to do is how to accomplish the tally. Now, how do we get the tally? So tally depends on the frequency. You have to get the frequency before you get the tally. Or better still, you can get the tally before the frequency, depending on how you decided to consider it. Okay, let me consider the third one, and you see how you can consider the tally before the frequency if you want to. So let's pick between 55 and 59 and see how it goes. So between 59, so we first of all see 55. So between 55 and 59, we have 1. So I'm going to write it here. 1. I'm going to see again. I'm having 2. So I'm having 2. So 59. I'm seeing 2. So this is 3. I'm seeing 3, you see. So 4, it's located 4. Now I'm seeing 5. Now rather than writing another one, so you just need to cross it. So the difference between 4 and 5 is that the fifth one, for the fifth one you cross it. So you have a cross. Then that means this is a 5, complete 5 now. So if it's a 4, you will leave it uncrossed. It's just 4. But immediately you cross it, that means it's a complete 5. So we now move to the next one where we have 50. Okay, we have 1. Okay, that's another one. That's 6. So we have 7, we have 8 here. So we have 8, okay. We have another one, let's see, okay, another one. So that's the 4. So I see another one, now I'm going to cross it. 10, okay. I mean, this is 11, so I guess something is wrong somewhere with the value. So let me still see whether this is still tally. So we have 8. So this already tally. So I can decide to draw this out. This is 4, 5, 6. This is 6. This is 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So here I'm saying 11. So let me even calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So that means
this is 11. Okay, let me see the next one and see whether it tallies with this.
60 and 64. So we have 1, we have 2, okay, 1, 2. Then we have 3, okay. We have 4. Then we have, okay, we have 5, so I can cross now. So we have 6, okay, 7, okay, 7. We have 8. We have 8, 9, 10, 9, 10, 9, 10. Okay, let's see, 11. 11, 12. 11, 12. Okay. 55 and then 49. So let's see. We have 1. We have 1. So I can write it down. 1. So I have 2. 2. I have 3. 2, 3. 3. 3, 3, 3, 3. Okay. Not seeing any again. So 3. I have 4. Okay. 4. 5. So it's rule out 5. Then I have 6. Okay, I have 6. So I'm still expecting to see 1. So, okay, that makes it that this is 6. This is 6, not 7. So this is 6. So the next one I'm going to look at for, okay, the last one. So which is 70. So this is 1. This is 1. And then we have 2. I'm saying it 2. So I'm saying 2. 3. I'll make the right thing. 3. So 3. 4. I'm saying 4 now. So 4. So 5. Crossing it. 5. Then I'm making use of the next one. Then 6. So you see, 6. So the value is taken to be 50 now. So that is 50. So that is the frequency. So now I haven't get all this. Now we can now make use of these to get our histogram. Because sometimes it could not be just a straightforward question. Sometimes
you could be given this string and then you just have to draw your histogram. So and then sometimes you could be given to.
So either the way. Then let's proceed and draw our histogram. Now, when you are drawing your histogram, you are expected to leave a space before you start drawing. You understand? And then your frequency is going to be on where your interval, your class boundary will be here. So your class boundary will be here. So you have, let's say this is 45, this is 49. Now, when you are drawing your class boundary,
if you actually look at this, this is the class interval. Before you can draw, like I said we're going to make use of the class boundary. So that means that
in terms of the class boundary, we'll make use of, we need to create a class boundary. And how do we create a class boundary? So we are going to look at that just in a moment. So let's just make our class boundary here. So our class boundary will be there. So in terms of our class boundary, what you're expected to do is that you are going to add up these two together. You understand? Then you divide it by 2. So let's do that. So we have 45 plus 50, so that will give us what? That will give us 95. Is that not? So 95, as it were, so divided by 2. So that will give us what? That will give us 4. This is 14, so this will be 47.
Is that okay? And that will be 2. This is, sorry for that. So this is 4. Then this is 15, that's 57.5. So that means you're deriving 47.5 between these two boundaries. So
better still, we're going to make use of these 0.5 as it were. So we're going to okay, we are going to make, so we have 45.5 here. So this one will be what? Now this one is increased. That means this will be increased by 5.5. This one will be what? Will also increase by 5.5. So this will be reduced, this will be reduced by 0.5, this will be increased by 0.5, so we have 49.5, you see? So this will also, that means that what happens to this will happen to this, so we have, we're going to have 49.5 here, so this will be what? 54.5. You see, this and this must tally, this and this must tally. That is exactly what we are trying to drive at. And if you like, you can actually reduce it by 1 or increase it by 1, as the case may be. But it's better you use 0.5 as it were. So we have 54, to reduce this by 54.5 to 59.5. So we have 59.5 to 64.5. So 64.5 to 69.5. And finally, 69.5 to 74.5. So that is the boundary. So we're going to make use of the boundary in our histogram. So in order to do that, so you remember that we said we have 45.5. So this place will be what? 49.5. So the next one will be what? Will be 54.5. The next one will be what? Will be 59.5. then the next one will be what? Now, if you look at this, apart from the first one that I write here, so the next ones I'm just writing this one, because the first one here is the last one here. The first one here is the last one here. The first one here is the last one. So you all see that the values are
just like that. So there's no need for me repeating any other one. So then after picking the first one, I will just be picking the rest.
From the upper side. We call this place lower side, we call this place upper side. So we'll be picking it from the upper side. So we have 64.5, then we have 69.5, and finally we have 74.5. So we can now start making our drawing to beat up the frequency. So I can decide to use 2, 4, 6, 8. Okay, that means you are expected to use 2 centimeter, represent what? 2 units. Because these are unit 2 increments. So we are using, if you measure this place from here to this place, you should measure with your ruler 2 centimeter. So which will represent the 2 units that we placed here. So
drawing now, we now make use of that. The first one will go all the way to 6. So I'm going to have 6 here, downward to till where? So this is it. It's going to come here. So below here. So that's 6. But the next one is 9. So that means this one is going to go in between these 8 and 9. So it's going to be in between. So I'll have to take a drawing. I'll extend to this side and then go to here.
So then the next one will now be 11. So 11 will go higher than the 12. So it will be this and then this. So the next one will be 12. Then it will go up. Now, if you notice, what the 12
starts from where? The 12 starts
from 98.5, which is exactly where I am. So I'm not, that's why I'm just picking it from the edge and then extending and reducing it. So it gets down to 45. So the next one is 6. So 6 to this place. So I will just locate 6, then bring it down. Then from there, we can now make use of the last one, which is from 69.5 where we are to this place, which is also 6. So I will just make use of this. So this is a typical histogram chart that we could use to represent our data. Look at the measure of center of tendency. Now, when we are considering this, there are some basic understanding we need to make here. This is where we will be looking at the word mean, media, mode, and the rest of them. So basically, we are going to look at this for the start. Now, looking at this now, and we get this. If you consider what we said earlier, we said we have data which are grouped and ungrouped. Now, in terms of the ungrouped, we said we're going to consider a typical example of that. For example, we have, let's say, in a class of 10 students of the following age. So let's look at the ages that we have. So we have 10, we have 15, we have 12, we have 9, we have 6, we have 12, we have 11. 1, 2, 3, 4, 5, 6, 7. We have 10 again, we have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have 12. So if we have this age now, we can consider this to find, in the interest of what we are looking for, to find it under the ungrouped data. So let's consider to find mean for ungrouped data. When you are finding mean for ungrouped data, what we are simply finding, in other words, not to actually make the things bogus, is we are looking for average. That's another word you can use for mean. But in professional terms, in statistics, we don't call it average. You understand? We refer to it as mean. So how do we look for that? So we call it expression, which is Fs all over F, as the case may be, all over N. So this is the formula we apply when we are considering what? We are considering mean. So what do we mean by this? This means that this symbol is showing that it is this is showing that is what is a mean symbol for the ungrouped data. Why this is showing the total of x. X stands for variable. So when we consider variables, we say variables are data or facts that change. So they are values that change when you consider what the word variable is. So the variables which changes from one student to another, which is 10 for one student, 15 for another student, 12 for another student, changes. So we are now saying that this E stands for summation. We are summing all these variables together. So summing all the variables together divided by the total number of students we have, which we take to be what? To be 10. So we should take note of that. So then find this mean, so it will now be what? Summations of all our variables, which is 10, 5, 15 plus 12 plus 9 plus 6 plus 12 plus 11 plus 10 plus 12 plus 12, all over how many students? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All over 10. So addition of that will give us the what? The mean. So let's try to add. Now we have the additions of this, which is what? 10, 15, 12, 9, 6, plus 12, plus 11, plus 10, plus 12, plus 12 that we have, will give us a total of 109. So over 10 of the mean will be what? 10.9 as it. Please, I hope we got this using your calculator. I believe that this is exactly what you get. So using this to find our mean, we can as well use this exact question to find the median and the mode as well. Now, in the situation whereby you are expected to use any of this, to use this particular question to solve the median, you are expected, what we are just expected to do on group data is to arrange according. Just make sure you arrange this the way it is to get the median. So we just have to. The media is still more like what we've done before in terms of using the on-group. So what the basic thing we have to apply when you're actually working with on-group data in finding media is to rearrange your data in either ascending or descending order, as the case may be. So if you decided, you can decide on your own to arrange this in ascending order, or you can decide on your own to make it descending. But you actually see the essence of rearrangement soonest. So in terms of rearranging now, sort this. So we are going to sort it as from the smallest to the highest. So we are going to have 6 to be the first, and then followed by 9. Then we have 12. Then another 10. We have 10. We have another 10. Then we have 11. Okay, we've mentioned this. We have 11. Then we also have 12, another 12, another 12, and then so we have 4 12s and what? And the last one, which is 15. The next thing we are going to do is that we're going to count from the right, and we're going to count from the left. So we're going to pick the center. The center value is our result in terms of media. The center value after arrangement is our result. So how do we do that? So you can decide to cross from the right and cross from the left, cross from the left, cross from the right, and you will find out that the center one will actually be your value. So we have cross the one, cross another, cross one, cross one, cross one, cross one, cross, and make cross. Now if you look at this now, we are expected to see the last middle standing, and we'll call it our median. But unfortunately here, we are having two values, which if you cross, we're not going to have any value. So in order not to lose out in terms of finding our result, what we are going to do is that we're going to pick the last two that we have in the center. Now we're expected to see, note that, let's assume that we have these data. Let's assume that these are the data that we have. Let's assume that these are the data that we have. We cross one, cross this, then the center one, we'll call it our median. But now that we're having two values that if you cross, then we will not have any value. So what we are expected to do is that we are going to pick the two out. So we're going to pick the two standing out, then we add it together. Then we will now find the average of the two. Then finding the average of the two, so pressing your calculator, what do we have? I believe this is what we have after our calculation. So we are now expected to have what? If we divide this by this, we are expected to have what are we having? Is this correct? All right. So this is what we are having as our media for this particular question. So after this, we now look at the third one. How can we use this to generate the third one? So we say mode. Now, one thing you should know about mode is that mode is the highest frequency of a data. The highest frequency of a data is referred to as our what? Mode. What do we mean by that? What we simply mean by that is that in your data, the value that occur most highest is your what? Is your mode. So which value do we consider to be most highest here? How many 6 do we have here? We have just 1 6. How many 9?
Just 1. How many 10? We have 2 10. How many 11?
We have just 1 11. How many 12? We have 4 12. How many 15? We have 1. So therefore, we have our mode to be what? Our mode to be what? 12. Because that is the highest value that we have. We have our mode to be 12 because that is the frequency, the highest frequency value that we have. Now, let's now assume that we have a question like this. We have 6, we have 9, we have 10, we have 12. And we are asked to find mode of this particular question. So what do we call? Now, in this particular sense, there's no highest because 6 is 1, 9 is 1, 10 is 1, 12 is 1. So in this sense, there is no what? No mode to generate for this. Now, but let's now assume that we have this another sample as a question. Let's assume that we have 6, 9, 6, 12, 10, 12. Let's assume that this is the value that we have. Now, in having this kind of value, what do we say? We have how many 6? We have 6 to be 2. We have 9 to be 1. 10 to be 1, and 12 to be 2. In this one, we can call it, we have a bimodal, because we have 2 highest. We can't distinguish which one we can call modem. So we can say we have a bimodal values as our modem.